All right, welcome to Chapter 4, Section 3, Part 2. Okay, so this is the third section, Part 2, and we've already done reflecting graphs. Now we're going to talk about symmetry. Okay, last section we talked about reflecting. Now we're going to talk about symmetry of function graphs. Okay, the objective is to reflect graphs and use symmetry to sketch graphs. All right, so we have a bunch of different words, or two different sets of words that we need to talk about what they mean. We first have this phrase called the axis of symmetry. We actually learned about this when we were graphing parabolas, but let's just restate what this is. So if we have a parabola, I don't like that one, let's say that looks like this. Okay, what is the halfway point that cuts that parabola in half? That would be considered the axis of symmetry. So for this one, it would be the y-axis. That's what cuts that in half. Now, it doesn't necessarily have to be a specific axis. Let's say we had a parabola that went through 1 and 3. The axis of symmetry is the halfway point between, so it would go through x equal to 2. Okay? We could also draw a sideways parabola. I mean, there are different options for axes of symmetry. We could draw that goes sideways, and then we'd have an axis that goes right through the middle that way. So the axis of symmetry has many different meanings. Now, points could also have graphs could also have points of symmetry. For instance, if we put a circle graph on here, that would have a point of symmetry, and the point of symmetry would be the center of the circle, and the center on this one would happen to be 0, 0. Okay, what else could we have? We could have, I don't know, let's make a shape that looks like this. Okay, that looks like kind of like a mustache here, but it also has a point of symmetry, and the point of symmetry on this one would also be right there at the origin. So if you flip the top portion of this mustache over, it would line up perfectly right on top of the other side. Same thing with the circle. If you folded the circle in half about that point of the origin, it would be right in the middle. Okay, so we're going to talk more about these basic words in a second here. All right, first thing we need to figure out, we need to be able to figure out the axis of symmetry, and we only figure out axis of symmetries for quadratics. So anything that has a power of 2. Okay, so if it doesn't have a power of 2, we're going to do something differently, but this is specifically for a x squared graph. Okay, so here's our equation. This should look familiar. We've done this before. Here's the equation on how to find the axis of symmetry. We did this when we were graphing parabolas a couple weeks ago. So here's our equation. We're going to find the axis of symmetry. So x equals negative b. My b value, remember, it goes a, b, c. So my b value is negative 4. So negative 4 all over 2 times a. So 2 times a, my a is negative 4. So my axis of symmetry of negative 4 would be positive 4. 2 times negative 4 is negative 8. So my axis of symmetry is negative 1/2. Now, what does that tell us? And if you look at the graph here on the right, I've graphed this negative 4x squared minus 4x plus 6 for us. And if we look, here is negative 1/2, and we draw a line straight up, it cuts that parabola right in half. So that little formula, negative b all over 2a, will give you the axis of symmetry for any x squared parabola graph. And that's what we've done right there. So x equals negative 1/2 is our axis of symmetry. Now, x cubed graphs, so if we're looking at x cubed graphs, they don't have axes of symmetry, they have points of symmetry. So the point of symmetry formula is here, and we're not just finding x values, we need to find both the x and the y. So we're going to need to find the x and the y. So first let's do part 1. X equals negative b. What's my b? Remember, it goes a, b, c, d. We have to add one more letter. So my b is negative 3. So negative 3 all over 3 times a. 3 times a. My a is negative 1. There's nothing there, so negative 1. So this is positive 3 over negative 3. So my x value is 3 divided by negative 3, which is negative 1. Now, that's part 1. Okay, we need to do part 2 here. We can't just find the x value, we need to find the y value too. So we're going to take this x value and we're going to plug it back into our original equation. Let me get rid of this marker here on top of the equation. So we're going to plug in x equals -1 into our original equation and figure out what y is equal to. So -1 cubed minus 3 times -1 squared plus 2 times -1 minus 1. Let's do a little bit of algebra. -1 cubed is -1, so I have -1. -1 squared is +1, so I have -3 times +1. 2 times -1 is -2, and then I bring down my -1. So let's see what y equals. -1 is 1, minus 3, minus 2, minus 1. So I get a y value of 1 minus 3 is -2. -2 minus 2 is -4. -4 minus 1 is -5. So my point of symmetry should be -1, -5. And where did I get that? I got that from my x value, and I got that from my y value. Okay, so let's plot this point. Let's plot this -1, -5. Okay, and I go right over here to my graph. I've already graphed this out on the calculator for us, and if I find the point -1, so 1 to the left and 5 down, you can kind of tell that that's right in the middle of that graph. Okay, half of it's on the left of it, half of it's on the right of it. That is our point of symmetry. Okay, step 1, use the small equation. Step 2, plug that number into the original function. And that's very similar to when we used to find vertexes to graph the parabolas. All right, next part. Moving on. So we have 4 different types of symmetry. Okay, this is symmetry type number 1, and this is symmetry of the x-axis. Okay, so if I look just here at the red graph, if you notice the top half of the graph, if I flip that over the x-axis, it lines up right on top of each other. So when we reflect over the x-axis, these line up right on top of each other. How do I know that it is reflected upon the x-axis? Okay, how do I know? The x value stays the same, so x is still x because it's just going down, but the y value turns into the negative. So let's say that this was at 1.5, 1. When I flip it over, this now is still 1.5 because the x didn't move, but now instead of a +1, it's down below, so it's a -1. So if the y's just change signs, we know it's symmetrical about the x-axis. So what I've shown here is 1.5, 1 turns into 1.5, -1. The y value switches signs. That's how you know it's symmetrical about the x-axis. Okay, number 2 is the exact opposite. This graph is on both the sides of the y-axis, and you could flip that over the y-axis, and instead of the y's changing, what changes now? The x changed. The x over here on the right is now x on the left. So let's say that this is at, I don't know, just say that this, I know it's not, but let's say it's at 1, 2. The one on the right here is at 1, 2, this point right here. When we flip it over, instead of being 1, -2, it's going to be -1, 2, because the x changes now. So down below we have our rule. When we're talking about symmetry over the y-axis, your xy, I don't know, let's just do at any point. Let's do 2, 3. Your xy changes to -xy, so -2, 3. If that's true in your graph or your equation, then we know it's symmetrical about the y-axis. Okay. Symmetry number 3. We talked a little bit about this in the last section. Now we're going to talk about symmetry over the line y equals x, and that's this dotted blue line here. That's the line y equals x. And if you notice, this red graph, if we flip that over that blue dotted line, it will line up perfectly with each other. What do we notice about the points now? xy turns into yx. So let's say that this blue dot down here, let's say that that blue dot is at 1, -1. Now our new point, if we just flip them, is going to be at -1, 1. And if we notice, -1, 1 up. And that's true. So let's just come up with a new one. So they just flip spots. So let's say our original is at 4, 6. Our new one is going to be at 6, 4. And that's how we can tell if it's symmetrical over the line y equals x. And last but not least, we have symmetry number 4, which is symmetry over the origin. Okay, if you notice here, half of the graph is to the right of the origin, half of the graph is to the left. And now what do we notice about the ordered pairs? XY turns into negative X, negative Y. So this point here, let's say it's 1, 1, one to the right, one up. If we follow the origin, it's going to turn into negative 1, negative 1. They both turn into negatives. So let's say we have a point 4, negative 3, and we want to see if it's symmetrical over the origin. The 4 is going to change signs, so it'll be negative 4, and the negative 3 is going to change signs, and it's going to turn into a positive 3. Okay. Now this is it's pretty confusing stuff here, so we're going to take some time to go over this and make sure that we do it correctly. But the last thing we're going to do is we're going to test our symmetries with a specific example. Okay. So here's our equation. We're going to do all 4 tests with this same equation. So I'm going to do x to the 4th plus y to the 4th equals 1. And we want to test if it's symmetrical about the x-axis. Okay, so we're going to go back to that one. And what do we notice here? Let me get rid of this red here. What changes? We're going to change y to a negative. That's what changes. X stays the same, but y is going to change to a negative. Okay, so if I go back to our problem, and all we change is our y value to a negative, we're going to see if it's the same thing. So x to the 4th plus, we're going to change the negative y to a negative. Now, let's see if if this new equation is equal to the original, then we know it's symmetrical about the x-axis. So let's see. X to the 4th plus, what's negative y times negative y times negative y times negative y 4 times? What is that equal to? Negative times a negative times a negative times a negative is a positive. So is this the same thing as this? Yes, it is. So it is symmetrical about the y-axis, or sorry, the x-axis. Now let's do the same thing for the y-axis. Let's go back to our page, and we're going to test it. What changed in this one? xy turned into negative x positive y. So only the x is changing. So if we go to our problem now, and we're going to now change our x to a negative, is negative x to the 4th plus y to the 4th equal to 1. Negative x times negative x times negative x 4 times. A negative times a negative times a negative times a negative is equal to a positive x. So is x to the 4th plus y to the 4th equal to 1? And this is the same thing. So as long as this and this are the same, we know it's symmetrical about the y-axis. So this is also a yes. Okay. Now let's do the same thing with the next two. Our next line of symmetry is the line y equals x. What happens there? xy turns into yx. All we're doing is flipping the x and the y. So let's flip the x and y. So here's our original. Now it's going to turn into y to the 4th plus x to the 4th equals 1. Is this equation the same as this one? It doesn't look like it, but you tell me. Is 3 plus 2 the same as 2 plus 3? If the order doesn't matter when you're adding, these two are the same. So yes, it is symmetrical about the line y equals x. And last but not least, we're going to test the origin one. And let's go back and see what the origin one means. The origin was xy turns into negative x, negative y. So both of them need to turn into a negative. So negative x to the 4th plus negative y to the 4th equals 1. Well, we just talked about these negatives to the 4th. They're both equal to positives. So is x to the 4th plus y to the 4th equal to 1? And if this is the same as this, yes, it is symmetrical about the origin. And if that didn't make sense, we're going to make sure we do a couple of examples in class. But this is a general introduction to symmetry. And this is a pretty hard topic that we're doing here. We're getting later into the semester, so we're getting into some harder stuff. That's it for today. I will see you tomorrow. Have a good rest of the night. And once again, see you tomorrow.